morning, class. Today you are in a first grade math class where we are learning about our place 10 values. And today we're going to be practicing with our base 10 models, which are our blocks, which I will talk about in a few seconds. Now, when we talk about place values, here's what I want to emphasize to make sure you understand. So I'm going to be using the example 23 today, okay? So we have the number 23, right? So we have 23. We have a 2 and a 3. So what I mean about place value is that the first number that you read from right to left. Now, this is important. I know we read left to right, but I'm talking about the other way, from right to left. This one right here is called the ones place, the ones. And then the 2 is called the tens place. Now, why do we call it tens? That's why we're going to use our blocks today. So, these are our blocks. We have blue and green. Now, the colors don't mean anything. That's just what I have available. So, if you guys get a different color, then we are not going to complain or argue about it with our classmates or teammates, okay? We have our base 10s. These are called base 10 blocks. Why are they called base 10? Because if we also have these single ones. These I have white ones. You guys might have blue or a different color, okay? So, but they are single. They are not in a block on our base, okay? But let's count. Let's count how many of our single ones makes up a 10, okay? So let's say 1, 2, 3, 4. Oh, it's falling a little bit. 5, 6, 7, 8, 9, and 10. If we see 10 of our ones, 10 ones makes up 1 tenth place. 1 tenth place, sorry. Now, if I ask you to show me the number 23 on your fingers, are you able to show me the number 23 on your fingers? Good job, Damien. Yes, we can show the number 23 by showing a 2 and a 3. Because we know 23, that's 23, right? 2 and a 3. What if I want to count 23 on my fingers? Am I able to do that? If I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I count again, what happens if I get confused? I can count 23 if I have, my friends with me. I can count my 10 fingers, my friend's 10 fingers, and then I can borrow 3 fingers from another friend. But can I do that in an assignment? Can I do that at home? Can I do that in a test? No. What I can do is think about our base blocks, okay? So we have a 10 and a 10. That's 20, right? Because 10 plus 10 is 20. Now, all I need to do is get 3 of my single ones, and then I have 23. See, 2 tenths and a 3 makes 23, right? So another way we can say this, remember we have to also think about the way we are saying our words, is 2 10 blocks and 3 ones equals 23. 2 10 blocks and 3 ones equals 23. Now, in a few minutes, I am going to pair you guys up in partners, and I'll put you in groups, and I'm going to hand out some blocks, and I'm going to say numbers, and I want you to show me that you can do the blocks, okay? I want you to show me how the number comes up when you're doing the blocks, okay? I'm going to go around making sure everybody understands. I also, for some of you, I want you to also get a piece of paper and draw it out, because what happens if we're at home and we don't have blocks? What else can we do? We can draw out our blocks. If we just have a piece of paper we can draw out 10 squares on top of each other, right? And then that can be our base 10. We can just draw it out. We don't need to have the blocks. There are different ways we can do it, but as long as we understand that 10 single blocks is 10 blocks, and we can count it out by tens, then it makes it easier for us to count, right? What another way that I can count is if I say one finger is a 10, right? So I can count by tens. 10, 20, and then maybe on my other hand, I can count my singles. 1, 2, and 3. I have 23. There are different ways we can do this. It's just right now, I really want you guys to understand and focus on the blocks because that's what we have access to at the moment. If when we're at home, we can think about different ways. We can use our fingers to count to tens. We can draw it out. But right now, let's really focus on using our blocks, okay? Now, the reason why this is a good element to use or a good model to use in a math lesson, specifically for ELL students, is that when it comes to blocks, students are able to look at more of the information and visualize what they're learning about. When I give them just verbal instructions, they might be confused. When I mentioned the number 21, some students will be able to do their fingers, 2 and 1 equals 21. Or they'll just start counting 1, 2, 3, 4, 5, and then they get lost. So when it comes to blocks, they can count and visualize, okay, 10, and then 10, and then we know some of us know our basic math, which is 10 plus 10 equals 20. So all you gotta do is just find the single ones, and then you have another number when you put them together. And then for our ELL students, this is a good way to put in our verbal skills, our oral skills, our language objectives as well, because we are using our words as well. We are saying 2 10 blocks is 20, or 2 10 blocks and 1 1 is 21. And so we're making sure our academic language is being implemented into our lessons as well. And with the blocks, the kids can understand, can visualize the language that is being used at the same time as the models that is being used, and they can visualize it. In my lesson plan, I mentioned that I wanted the kids to draw out the blocks so they can look at it in a different way, saying if they don't have it physically with them, they can still draw it out and it will help them more. So that's also why I wanted to implement that drawing part, because during maybe an assignment when they're at home or when they're doing a test, they don't have the physical objects with them, and it's easier for them if they can draw it out. They can count up to 10, that makes one block, and then they just add the singles next to it. I wanted to implement that to make sure that they know they don't have to have the blocks with them. It is a good thing to have them, but if they don't, there are different ways that we can implement this model in our everyday lives.